boy. Count slow. There's a hand. I got it. Oh, I'm sorry. That's a slope. Those slopes are correct. This one's negative, but yeah. Find your slopes right. Good. Hunter, what you got going on? Yep, that's the slope of your friend to the water fountain. Okay, I see progress. See progress. So, for the friend has to go up one, over one. Actually, maybe you counted 1, 2, 3, 4, 5, 6, 7. The friend goes up 7, 1, 2, 3, 4, 5, 6, 7, and right 7 to get to the water fountain. Um, so 7/7 is just 1. So actually, your friend is just going up 1/1 to get to the water fountain. Maybe I'll even draw that. So your friend's equation thinking about slope-intercept form would be y equals 1x, and I typically don't write a coefficient of 1. And then the y-intercept here is 1. 1x plus 1. All right, now you are a little more difficult, mostly because the picture isn't complete for your equation. So you go up 4 left. Up 4 left 8. And left is negative. So the slope for you is up 4 left 8. I'm going to write that as a negative. And that's the equivalent of negative 1/2. So your journey to the water fountain has a slope of negative 1/2x. So up 1, left 2, up 1, left 2, up 1, left 2. 1, 2, 3. 1, 2, 3, 4, 5, 6. Oh, you're starting here. 1, 2, 3, 4. Up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2 gets you there. Well, we need to figure out what that b value would be. Did anybody come up with a guess? It's difficult. It's around 6. I'm gonna extend the graph so I can see. So this is 5, and then here's 6. So up 1, left 2, up 1, left 2. It's actually right here in the middle. 5.5. Would have been great had it been an integer, but it's not. You'll end up going from here to here, right through 5.5. Okay, so those are our journeys, hopefully. Now it says to It says, is the solution of your system the fountain? So the fountain's coordinates, let's go ahead and write that down. The fountain is at 1, 2, 3, 1, 2, 3, 4. So the fountain is at 3, 4. Is this the solution? So guys, yesterday we practiced substitution. So why don't you go ahead and use substitution and try to justify, is 3, 4 really a solution to these two equations? Can you substitute with two linear equations? So circle 1y and remove it. Replace it with the other expression. And see if you can solve. It should be easier because there's no x squared. Who was absent yesterday? Okay, guys, I'm gonna do a substitution problem. You actually did this in Algebra 1. And we did it yesterday with quadratics. So just try to stick with this. This is a review of the concept from yesterday. So substitution means like you remove one variable. So I'm going to take this y out and I'm going to replace it with the other expression. So I'm writing a new equation. It'll be x plus 1 in the y spot, negative 1 half x plus 5.5. That's substituting. And then you solve this equation. So your steps might be different from mine. It's okay. I'm going to plus 1 half x to the other side. That's 3 over 2x. Are you okay with that? So 1, you could have written 1.5. That's okay, but I did 3 over 2. I just prefer that. Minus 1. And now I'm set up to multiply by the reciprocal. My conclusion was that x equals 3. Did anybody else get x equals 3 in their substitution? Ellie, did you get x equals 3? Finish it out. Finish that problem out. X equals 3. When I multiply by the reciprocal, 4.5 times 2 over 3 is like 4.5 times 2 is 9. 1 times 3 is 3. And then you reduce it. Okay, and x equals 3 checks out with the fountain. When I look at the ordered pair in the fountain, x was 3. So that's good. Our system's looking good. Now we're going to don't stop. Remember with systems, you don't stop there. You must find y. So I'll wait. You guys go ahead and find y. Alright, to find y, I'll plug my answer into the best place, which here is the top. And now we have verified that our solution 3, 4, the fountain, works for both our equations. So you and your friend were able to meet up at the water fountain. All right, when you're done, get out your homework. Take a look at the work for that.
No.
Oh,
One
there's
on
one.
Friday, one is on Monday. Right here. Friday.
All right, guys. So I hear some of you did all the work for these. So these are already graphed for you. You know, and the directions say use the graph to solve the system. So remember, when you solve a system, you're looking for points of intersection. So you can just look at the graph. So I'm looking here, and these don't intersect, so they have no solution. I'm wondering if you did all the math, if you got imaginary solutions. You should have. Number 8, they cross in exactly one place, -4, 1. So that's the answer. Number 9, I see 2 solutions. There's one at -6, 3, and another at -2, 3. And number 10, these go by 2s, so it's 1, 4, 4, 6, 8, 9, 9, 4. Already done for you. Just matching the points of intersection. How did it go by hand? Did you get any of it?
I did that one. I just got my
Okay, and then we did 19 together. Here's number 20. I believe I showed this in class, setting it up. So when you go back to check and see, did you set it up correctly? I mean, the answer is 1, -7. So if you got the answer, then you don't have to go through all the steps. But if you didn't, see, did you plug in correctly? And then right here, did you distribute the negative sign? Did you make it equal 0? Then you have this this quadratic to factor. That factors x minus 1 times x minus 1. So if you got stuck here on factoring, I'm glad at least you did the first half. You still need to figure out factoring. So when you set those equal to 0, you end up with only one x value. You plug that into the original equation, and that's where you get your y value. Anybody get this one right? Anybody able to get x equals 1? Okay, that's a good number. Oh, yeah, divide everything by 3. Yeah, dividing that by -3 is key. So if you had stuff there, I get that. You got it? Okay, did you find? Okay, did you answer 6? You were asking me yesterday. I'm not telling you. All right, I'm gonna switch to number 21. Yeah, this is your right. Yeah. So you did that now. You didn't make that correct. No. If you look there, that's what I have highlighted. It doesn't factor. So I did the quadratic formula. And whenever you get your imaginary, it is imaginary. There is no solution. They don't cross. All right, so I'm seeing a lot of you did the quadratic formula on 21, which is so great, very good. If you do the formula and you end up with an imaginary answer, and maybe you want to kind of write this down as a note. Imaginary solutions means no intersects, no solution. So if you end up doing the formula because you can't factor it, and you get an imaginary answer, that means those equations never intersect. So that's a no solution. Like the first graph. All right, guys. Any questions? All right, we're going to continue in the same section, but we're going to try elimination today. So we're going to review how to solve a system through using elimination. All right, so we're going to open your books to page 249. so I'm a full believer of the three reminder and pulling out the whole chapter, even half the chapter, hole punching it, and putting it in a three reminder. I've also seen students who've taken the time to rip it out and then just staple it. So you get it out of your folder and it's all stapled in order. And I think that's a really great way to use this textbook. So like so you guys have a test next Wednesday, so in a week. And then so before we start chapter 4, I suggest you go through and like tear out most of chapter 4 and either staple it or hole punch it and put it in a 3-ring binder. And that way it's kind of always with you instead of this like going back and forth. All right, so did you guys hear me say there's a test on Wednesday?
Tomorrow Wednesday?
Today is Wednesday. Yeah, today is Wednesday. So it's in 1 week. In 1 week. Yeah.
I thought today was Tuesday.
Yeah. So it's in 1 week. So you guys had a quiz last Tuesday, so that's a 2-week break before between like any type of formal assessment. So today we're doing elimination, and then tomorrow we're crafting inequalities. It's really not too bad of a section. I think it's easier than this section, and then that's it for the chapter. So we have 3 days to like really review and practice. Okay, so you'll probably remember elimination. You do a big plus sign and you add down with the goal of eliminating a variable. The one thing that's different about this is as far as I can tell, you always want to eliminate x. I'm sorry, y. Always eliminate y. I like that y. So what that means is that in your system, you need opposite y values. And you align like terms. So this one's already aligned. It's an x squared over an x squared, an x over an x. We have a negative y and a positive y. That's what I mean by opposite y's. And then the constants are on the other side. So setting it up kind of like terms stacked is really important. So when you add down 2x squared plus 1x squared is 3x squared. We're combining like terms. Negative 5x plus 2x, negative 3x. The y's are opposite, so they're eliminated. That's why it's called elimination. Negative 2 plus 0 is negative 2. You should just have a quadratic left if you add down correctly, and then you solve that either factor or quadratic formula. This one in this example doesn't factor, so they did the quadratic formula and they got an imaginary answer, so that means this system has no real solution. But from this step, you could have 2 real solutions, 1 real solution, or no real solution. Okay, who remembers adding down in Algebra 1 to eliminate variables? Yeah, we do it a lot. Okay. Let's go right to your assignment, page 320. It's 253, I believe. Is that what I put in lower? 252. 27 and 34. This is 253. I'm gonna do number 27 with you. And then I'm gonna do 33 and 34 because those will be the most difficult. And then I'll leave all the middle problems for you to try. So your textbook has these lined up pretty well. If I put a big plus sign here, the only thing I noticed is that there isn't an x squared term down here. So if you wanted to make it look the same, you could put 0x squared. If that helps you see, okay, I have an x squared over an x squared. I have an x over an x. I have a y over a y and a constant over a constant. So lining up the terms. So I'm going to go and add down 2 plus 0 is 2x squared. Negative 3x minus x will be a negative 4x. Opposite y's are eliminated. That's the whole goal, is to eliminate y. And then negative 5 plus 5 is 0. So this is cool. It's already set equal to 0. But now how do we solve this? How do we solve it? You could do the quadratic formula. I see a lot of you guys are using that. But this can also factor by GCF. When I look at the expression 2x squared minus 4x, they both divide by 2 and they both have an x, so I can factor by GCF here. If you don't like that, you are welcome to try the quadratic formula with this, okay? The goal is to find an answer. So if you're not good at factoring, you can do the quadratic formula for all of them, okay? So now I would, to solve these factors, I'm going to say, well, the first part equals 0, and the second part equals 0. So I take this GCF, make it equal 0. I take this factor, make it equal 0. So one of my answers is 0. I know on the quiz that there was a good handful of students that didn't acknowledge the 0 as one of the answers, but with the greatest common factor, 0 is typically an answer. And then I'll add 2 over here. And my other solution is 2. Yeah, don't stop. Go ahead and find y now. Okay. Man, where do you guys want to plug in x to find y? I think this is a smaller equation, so I'm going to plug in x here to try to figure out y. You can pick, do you want to plug in the top or the bottom? The bottom one's smaller, so it's going to be shorter finding y. So first I'll do x equals 0. The equation is negative x plus y equals 5. So I'm going to take the x out. My app is like overwhelming now. And put 0 in. And negative 0 is just 0. So y equals 5 is our first one. And we get y equals 7. Add 2, add 2. So we have two answers at 0, 5 and 2, 7. And this is one that you could try putting into Desmos to see if you could find So now I want to encourage you to skip all the way down to number 33. Alright, so that you try the hardest questions right here in class. And see if you can set it up and get started on it before I do. Skip all the way to 33 and try to set it up. Does anybody want me to wait before I move on to 33? Okay. Raise your hand if you're ready for 33. Got it. Okay, I'll do it. Gosh, that one doesn't look right now. 31 looks good. Alright, 33 does have a problem, right? Y is not opposite. If I add down just like this, I'm going to end up with 2y instead of canceling out. So take a minute to look. It's supposed to be a positive y and a negative y. Does anybody remember how you would solve it in algebra 1 with the linear? What could we do? We could multiply -1 through the bottom. Or I know in some classes, some teachers teach you to subtract down. Does anybody remember subtracting down? Okay, I'm going to multiply the whole bottom by -1. It's going to change all of their signs so that I have an opposite y value. It's really important you have opposite. So it gets distributed. This negative goes all the way through the bottom. So now this is my new system. Add down. More time. Negative confirm on one time. Yeah. All right. This looks like a situation where we could reduce everything divided by 5. So let's not try to factor this just yet. If you can divide all parts by 5, do it. And actually, I'm going to do both sides by -5. And so we're at 0 equals x squared plus 10x. (24). And I think you guys can factor that. Factor it and solve it. Because how do you factor this? X squared plus 10x plus 24. What would you come up with?
I did 6 times 4.
6 and 4. Word. 6 and 4. So I moved you guys very quickly into this section, but I knew you would still be practicing factoring and still be practicing the quadratic formula, so I moved along. So I totally acknowledge that you're still mastering factoring. That's still a part of practicing this problem.
Yeah, but we have to plug it into it. It's already multiplied by negative.
Yeah, you can plug it in actually anywhere. You can plug into the top. You could plug into the original bottom. You could plug into the negative. You could even plug it in here to the simplest one. To be consistent, I'm gonna go ahead and put it in the top. I'm gonna put both x's in the top. And so I would really have my calculator out to make that quick. How's this going, sir? Got it. It's not too long. It looks complicated, but how's this? Is it negative 144? Not totally confident in my work. If you copied my work, then mess it up. I'm erasing all the way to the front. I'm erasing all the way to the top.
How do you sort it? Did you put
I'm starting over.
I made it possible.
You actually can if you want to. You can plug in a lot of different things. You could plug in x squared plus 10x plus 24. This answer is negative 6, negative 4. Hey, you guys, that took a long time. I'm shortening your assignment. Everybody hear me? That took a long time. Right now, I gave you 7 problems. You guys, let's just do odds on this. So I don't want you guys doing homework forever. Let's just do odds. So I did 27 and 33. So you have 29 and 31. And only give you 2. Is that enough? If you don't feel like it's enough, do more. But I don't want you guys spending more than 30 minutes, 40